Welcome to Earth Engine tutorial episode 51. In this video, I'm going to show you how to create some high quality maps with customized projection. In order to follow this tutorial, you need to download the notebook example. You can go to the gmap.org. On the left side here, click notebooks and scroll down to find number 51, Cartopy projections. And then you can click the download icon. Download this one to your computer. So I already have this one here within my downloads folder. So let me cancel. Once you download the notebook example, you can open your terminal or Anaconda prompt to start Jupyter notebook. So I already have my command prompt here. I just need to type the Jupyter notebook, and then it will automatically open a link within your browser. Then just click the notebook. It should open this one. And so earlier I already executed the source code. If you want, you can also go to sale and run all. So you're going to run all these sales all at once, because this notebook, some of the code block takes a long time to run. So you might want to just click and run all. After that, you should be able to see all the results. And I'm going to hide the source code just to show you what the output look like. As you can see from here, right? So we are using the sea surface temperature data, and this is the default projection of Cartopy, but you can use all kinds of projections. So you can scroll down, you can see here, this can be easily customized, and you only need to change one line of code. Everything else remains the same. So it's very nice that we can use Python to create maps like this. Okay, so let's get back to the beginning. And in the previous episode, I think episode 50, I show you how to actually create a Conda environment, and then also to install the packages required for this one. As I mentioned before, this notebook require Cartopy package, and this one can be challenging to install on some Windows computers. So you want to make sure that you follow my previous tutorial how to install. And then you can come back to Xcode to run this notebook example. And we're also going to use the Cartopy module within the Gmap package. So this module was contributed by Kale Market, and also this notebook example. So a big thank you to him for his contribution. With that being said, let's get right into the source code. And so first of all, we need to import the libraries. We need the Earth Engine API. We also need the Gmap package. We also need the Cartopy, and we also need the Cartopy projection list. And we also import all kind of matplotlib and numpy libraries. So this one take care of all the importing libraries, and then we initialize Gmap and Earth Engine. This one is required because we're going to use Earth Engine to retrieve some data. So make sure you run this one. After that, we're going to get some data. So I can show you in here. This example, we're going to use sea surface temperature. So we're using the MODIS data, and you can just Google this one. Right click, and then you can search on Google. It's open the first link. And then from here, you should be able to see the data, what the data looks like. Data available from 2000 to 2020. And so this is the image collection ID. From there, you can see the bands, what kind of information image contain within this image. So for this specific tutorial, we're going to use this sea surface temperature. And you can see the unit is Celsius degree, -2 to 45. Sea surface temperature. And let's come back to here, and we are only using the temperature from 2018, for example, January to March. And then so this is basically a time series of images, and we apply a median filter. So basically we use the median value of all the time series values, and after that we only select the band we need. So in this case we're using the sea surface temperature, but we also change the band name to uppercase. So this is when you have a select function. The first one is the original name of the band you need, and this is how you're going to rename. So you rename it to uppercase, and once we have the data, then we can set the visualization parameters. So in this case also we just use there's only one band, so the sea surface temperature, and the minimum we set to -2, the maximum is 30 degrees. Keep in mind the maximum you can set up to 45, so up to you to change. We also customize the bounding box, so basically the reason we want to map, and in this case we use a basically -180 to so this is the lower left corner, longitude, latitude, upper right corner, longitude, latitude. So in this one here essentially is the entire globe, because for the South Pole and North Pole we don't really have data, so you can use -88, also +88. Okay, so once we have the data, we specify how we want to visualize it and also the reason, then we can create some maps. So all you need to do is to create a figure. You can think about this just like a blank paper. So we will create a blank paper, then we are going to draw something on the paper. It's the same thing. So we create the figure, and then we can use Cartopy to get the map. So the first parameter here is the Earth engine object, so it comes from here. If you want, you can shift tab on your keyboard to bring up the help documentation. Let me execute this too, actually, just to show you what it looks like. And once you execute, you can from here shift tab, it should bring up the parameters, so you can customize things to pass into the get map function. Basically you need the Earth engine object and also how you want to visualize, and also the bounding box. You can also pass in the color map, so this one we use plasma. Once we have the map, we can also add the color bar. So the first line of code actually is you get the things on the left, right, and the color bar here is the one showing in here. We are using the same visualization parameters from -2 to 30. We also want to put the color bar at the right, and so this is what it looks like, and by default it's going to be vertical. Also we set the title, so set the title, the label, this is what it shows in here, sea surface temperature. You can also change the font size, it's up to you. You can change it to a larger number if you want a larger one, right? So this looks pretty nice, only a few lines of code. And so all you need to do is to figure out like what's the general procedure to create a map using Cartopy. You will need an Earth engine object. This can be an image or it can be a blend of images. So if you have some other administrative boundary you want to overlay on an image, all you need to do is just to use the image to visualize. So once you visualize it, it changes to an image, and then you can use that to plot that on the map. You can set the specify the reason you want, also the how you want to visualize. Then you create the figure, and then you get the map plotted on the figure, add color bar, set title, and then you can add some additional things if you want. Lastly, you want to show the map. That's it. So this is the general procedure that you want to create a map. And as you can see from here, we didn't actually specify any projection. So by default, Cartopy is using the plate carry projection. So that's also the one, the default projection for Cartopy. If you want, you can just Google and then go to the Cartopy documentation. On here, you should be able to find a list of projections supported by Cartopy. On the right here also shows you a list of the projections, so you can click each one. But if you want, you can scroll down, right? So this one, well, it's being shown here. This the default projection that being used. It's actually this one. So if you scroll down, you can find some other projections. So if there's anything that you are interested in, or you need to figure out like what's the best projection for your application, for your region. And once you figure out which one you want, then you come here to find out the name of the projection, right? So for example, mobile or also graphic. So you can see from here, or Robinson. So load anything that in here, you can use it the same thing using within the Jupyter notebook, and you can scroll down to find all the projection supported. Okay, next let's come back to here. So how we can actually change the projection. As you can see from here, this is the source code we used earlier, and pretty much it's very similar. We create a figure, but we only add one additional line. So this time we are using so we already import the Cartopy.cis as a CCRS. So this one basically is the same as this one. So Cartopy.cis, or whatever the name of the projection. And then within the projection, you can provide some additional parameters to customize this, for example, the central longitude, and also the force easting or force northing, and also the globe. So you can provide. So in this case, we only provide the central longitude, right? So in the center. So this would be -180. It is near the Pacific Ocean, within the center of the Pacific Ocean. And what else? Everything else remain pretty much the same. So all we need to do is to, when we request the map, we also pass in the projection. So it's here, this one, right? And other than that, we use the Earth engine image, also the visualization, bounding box, color map, and the projection. So this is the only thing that's been changed, is to passing the PROJ parameter, and then set the value to your projection you want, right? So if you come back to here, right, get map, everything else is the same. So that's very simple and straightforward. We also set the title, but this time we don't set the font size. If you just pass in, I think by default it's maybe 12. The size might be 12, but we also change the color bar location. So earlier here we use the color bar is on the right, and then it's vertical, but this time we change to at the bottom, and then it's horizontal. So now the color bar is being changed to the location being moved to the bottom and horizontal. So this is what it looks like. And so if you figure out how to do that for one projection, you will be able to do that for any projection. So all we need to do is just to change this one, and all other lines remain the same. But we also add the coastlines, right? So if you want the coastline to be plotted on the map, you can do that using one line of code. And okay, that's it. So the next one is using the GUI homoloci. And oh no, this one is the Robinson. As you can see here, again, it's the same. CCRS.Robinson, and then central longitude, right? So this is the only parameter you need to customize. If you want to change the location, so let's say you want to change to maybe 0 degree, you can do that as well. So all you need to do, you can change this one. Oh, by the way, I might need to go back to, let me execute this one. So execute this too, and then we should be able to run it for any other data. So by default, earlier we use -180. So you can see here near the center, but if you change to 0, it's going to show you a different location. So you can easily customize the projection using different parameters, depends on the location that you want, right? So now you can see here, the center here right now is the near the 0 degree longitude, and if your country, for example, is in other location, if you want to put it in the center, then you can certainly do that for by changing the central longitude. Okay, so next one, similarly, this is interrupted GUI homoloci. You can see from here, all we need to do is just change this line of code, and we also set the title, everything else remain the same. So you should be able to figure out to that. And also one very commonly used is the equal Earth, and this one is similar to the Robinson. You can come back to here, right? Looks pretty much similar, with some slight differences between the borders. Again, you can customize the central longitude if you want. Also, you might, if you are interested in polar region or sometimes near the equator, you might want to use this one. Also graphic, and this one you need to pass in two parameters. If you don't know, you can shift tab to bring up here the central longitude and also the central latitude, and this is what it looks like. Also you might have seen this one on some textbook or some publications. Very nice. Okay, so lastly, I'm going to show you some of the examples that sometimes, because for projection, you might expect that you won't be able to get a perfect map of everything, like global scale, especially. Basically, we are trying to, when you do projection, you are trying to unwrap a 3D globe and to plot it on a flat map. It's going to get some distortion, and sometimes things we get very weird. So this is sometimes we call also the warping artifacts. Just like this example, we are trying to plot something near the South Pole, right? And depends on the region. So think about here, when you're trying to create a map with customized projection, you need to figure out what kind of a region you're trying to plot. And also, because for the data on Earth engine, pretty much most of those are at the global scale, so you can get whatever data you want. But when we're trying to create a 2D, two-dimensional maps, you might not be able to get everything onto, depends on the projection that you use. You might not be able to get everything on the map like nicely. So in this case, we're trying to plot the data around the South Pole, so -180 to 180. So basically all the longitude. But for the latitude, we start from -88 to 0, so to the equator. So basically half. This is the southern hemisphere. We're trying to plot the sea surface temperature for the entire southern hemisphere, and we use the south polar stereo projection. As you can see in here, this one takes a while to run, and it doesn't look good because you see some data in here, like some of those. You can also see the large distortion in here in the other continents. So this is not something that you would expect. And how you can resolve this issue is to basically reduce the region. So because think about when you are up above the South Pole, you look down and to the globe, you're not going to see the entire southern hemisphere because some of those are going to be blocked out. So you can basically reduce the region that you are looking at, and this is the example that's showing you how to fix the problem. So all the source code remain the same except that we add this line. So the zoom, basically the bounding box, the region that we want to look at, we change it to so -1 to -20. What does this mean? So in here we specify the corner. So -1 means this number. Okay, so this one is near the equator. 0 is the equator, and we change it to -20. So basically now we are trying to plot the data from the South Pole to the latitude south 20 degrees, so not the entire southern hemisphere, just part of that. And then you can see the data now looks much better compared to this one. This one looks less like a disk, and this is something like real data that you can plot. And so one last time, let me go through here some of the example. You can create your own customized map with customized projection, whatever reason you want. So whenever you're trying to create a map, think about what data do I need, what things I'm trying to map, and then think about what kind of projection is best for your study area, for your application. and then you can think about the region, specify a region that you want to map, and also think about the color map, what kind of color map is best for your data, and also where you want to locate the color bar, the title, everything. So you can all customize. If you look at the source code, all you need to just to fill in those things that you want to change, and you can use this as the building block to create some maps for to be included in any report or journal publications. Okay, that's all for this tutorial. If you enjoyed this video, please consider hitting the like button and subscribe to my channel. Hope to see you in my next video. Take care. Bye bye.